When it goes to actual implementation, we have identified that there is a need for a common AS4 interface between the AS4 gateway and our components. Let me do a preview here on why we are in this current situation and why we have created a backend interface specification that communicates with an AS4 gateway in a seamless way. So when it comes to implementation, there are many functionalities that we were hoping to remove the burden of implementing them from the member states and make a common component, a collection of common components that will do this in an orchestrated way. So this is it is materialized, it is realized in the component that you see here. It's the top connector. So the top connector receives a message, if it's a submitting message, it receives a typical payload message from the member state, the system, and then it has to do some specific things that are common among the top architecture. So first it does semantic mapping, then it does a data discovery, and then it creates the AS4 message itself to be sent. The data discovery module is there, and it queries some central services in a specific way that it's not only asking for an SMP, it is a little bit more elaborate. So we have decided to put this in our connector and not somewhere else. This means that we need to feed the AS4 gateway with a specific data and find a way to send the specific data and design the transactions between the AS4 gateway so that when we submit the message, the AS4 gateway will be able to configure itself dynamically because we have dynamic discovery, create some PMODs, and then also be able to respond with deliveries and notifications. What we did, and this is the requirements. So we said that this interface that we're going to implement should be based on something that exists already, and it is somehow implemented by the vendors. It should provide the information required to dynamically configure the AS4 gateway because we need dynamic creation of the PMODs. It should facilitate the decoupling of the dynamic discovery processes and their use in the AS4 gateways. We have seen in previous projects that when there is a need for dynamic configuration and discovery, we tightly couple the process inside the gateway, and this could have some problems when you need to update this agilely. So what we decided, and this is bullet 3, is that the interface should decouple the process of dynamic discovery, of getting the metadata, and just provide the actual values that the EP mode requires in order to successfully create it. And of course, it should provide a full interaction between the backend, so between the top connector and the AS4 gateway. And we have created 3 kind of transactions and messages: the submit, notify on error and on success, and the deliver. Okay. So let's see how we coupled with how we tackle the requirements. So it is based on the CEF conformance in the interoperability testing, this specification, the CIT. The CIT specification is already there. And if a vendor, an AS4 vendor, wants to prove that it is conformant with the CEF AS4 eDelivery specification, it needs to create this interface, the CIT interface, in order to do the conformance and interoperability testing. So this is why we started from there and try to expand as much as it needed, so that we can have a proper dynamically configured supportive interface. First of all, since this presentation is going to be a kind of a reference material for you, I think it's going to be disseminated later. There is a link of the specification. I think that we will not have that much time to go in detail on this specification, so please, you should have a look at the link there where it is described in high detail. What are the messages? The messages are simple AS4 messages. So the AS4 gateway knows already how to parse those messages and how to read those messages. That's a big plus. No security headers are used, so there is no need for signature and encryption between the backend and the gateway. It's a typical SOAP with attachments, where each payload, the business document, is carried as a separate payload in the attachment part of the software with SOAP with attachments, and referred to by their ID from the messaging header. Routing information from the backend, so the destination party, service, action, certificate, endpoint, URL, and everything that should be part of this information, of the routing information, are contained in the message properties of this user message. Typically, the message exchange process, we have the backend system. In this picture, you see that it acts both as corner 1 and corner 4. Let's go on a step-by-step basis. So, step 1, corner 1 sends a submit message to corner 2, and this is the first arrow you see, the first blue arrow. Then corner 2 sends a submission response message containing the outcome of the submit action to C1. So depending on the communication between corner 2 and corner 3, we have a synchronous or an asynchronous response. Then corner 2 sends the AS4 message to C3 using typically the CEF eDelivery AS4 profile, which means encryption, a signature, and all the things that are required by the CEF eDelivery AS4 profile. Corner 3 receives the message and sends an AS4 receipt back to corner 2. Also, C3 delivers the message to C4 using the deliver action, the one that we have defined in our interface. And also C2 delivers the AS4 receipt from C3 and informs C1 using a notify action. So it's like a multi-legged approach, a simple one between corner 1 and corner 2, and the strict and secure one between corner 2 and corner 3. The submit message, okay, I'm not going to go into details because this gets highly technical, but let me skim through this. So we have the submit message, which contains the full routing information and the service and the action. You can see it here. These are properties that you need to put as the message properties. So message ID, conversation ID, all those are all those are P mode properties that one must have in the P mode in order to submit something. Then we have the submission response, which is the message being sent from the AS4 gateway to C1 after the submission of the message. It contains the result of the submission. And this is the thing that it should be inside the message. One of the things that we should state here on the submission is that the AS4 gateways in C2, when receiving a submission message from C1, shall create a P mode for sending to C3 on the fly, using the message properties found in the submission message in combination with the CEF eDelivery AS4 profile. So we get the eDelivery CEF AS4 profile as a template, as a P mode template, and we fill the missing gaps with the message properties that we get from the backend. Then it should send the message using the new P mode and create and send the submission response back to C1 to inform about the submission results. So this is the implementation step that an AS4 gateway should do in order to properly support the CIT interface. Otherwise, it's a simple AS4 message. The same for deliver on the other side from the C3 to C4. So the message being sent from the target gateway to the data provider. And the actual message properties, what you need to have. And then the notification, we must have a notification when a delivery is successful from corner 2 to corner 3. And this is another AS4 message that goes from corner 2 to corner 1. And its messages. So all those things, the messages, the transactions, the actions, and the services, you can find them through the link provided in our first slides. And when you are ready, we can even start doing some tests with our connectors if you think that you can participate. So I try to be quick so that in case you need some more details on how technically this can be achieved, or if you have some questions on the profile and the specification of the interface, please feel free to ask.
Thank you very much, Jerry.